To find the acute angle alpha in degrees that satisfies the equation alpha equals arc sine square root 2 over 2, you want to ask yourself, where is sine equal to square root 2 over 2? So if I were to draw where sine, first off, because I know all students take calculus, sine is square root of 2 over 2 either at 45 degrees or at 135 degrees. However, only one of these is the correct answer for arc sine. The thing about arc sine is in order for arc sine to be a function, you have to limit its range. So one of these answers is in, let me tell you, arc sine lives in one of these two spots. So if you have a positive value that the sine equals, in this case it's equal to positive square root of 2, arc sine will only exist in the first quadrant. So our answer is 45 degrees. Arc sine doesn't live in the second quadrant, so this answer could not possibly be it. Arc sine does not live in the third quadrant or the fourth quadrant. However, it does live in the -1 quadrant. So you will get some answers for arc sine like negative 40 degrees. That's possible. In this case, 45 degrees is our answer. Evaluate the expression without using a calculator. Give the result in degrees. Arc sine. So arc sine, 60 degrees and 120 degrees. These are the two spots where sine equals square root of 3 over 2. There's actually an infinite number of spots where sine equals square root of 3 over 2, but they're all coterminal at these two spots. However, arc sine only lives in either the quadrant 1 or quadrant -1, so there's only one answer that satisfies sine equals square root of 3 over 2 where arc sine lives, and that is 60 degrees. Arc cosine square root 2 over 2. So where is cosine square root 2 over 2? That happens at 45 degrees. It also happens at 315 degrees. It happens in that quadrant as well because all students take calculus. It tells us that cosine is the only positive one in quadrant 4. So cosine will equal square root 2 over 2 when you have a 45-degree reference angle. Now, where does arc cosine give you answers? Arc cosine lives either there or there. So we have one value that lives where arc cosine lives, and so our final answer is 45 degrees. Find arc cosecant of -2 without the use of a calculator. So this problem, essentially, arc cosecant of -2 is the same as arc sine of -1/2. Knowing this, we can think in terms of the sine world, which is a little bit easier to do. So where does sine equal to -1/2? Knowing that all students take calculus, oh, that's a T, that didn't work too well, let's try that again. All students take calculus. We can see that sine is positive here, first quadrant and second quadrant. So it's negative in the third quadrant and the fourth quadrant. -1/2, that's a 30-degree reference angle. So drawing a 30-degree reference angle, this would be 180 and 30 is 210, and this would be 330. But this one could also be -30, depending on which direction you move. If you go around this way, it's 330. If If you just go back, it's negative 30. Now why that negative 30 is important is where does arc cosecant live? Turns out arc cosecant lives either the first quadrant or -1 quadrant. So the answer that's appropriate is the negative 30. That's the one that lives in the -1 quadrant where sine is -1/2, therefore cosecant would be -2. When you're doing arc functions like this, it is very important that you know where they live, what possible range they have, because there's only certain values that they can take on. Okay, the answer, therefore, -30 degrees. Arctangent of 1. Where is tangent equal to 1? Tangent equals 1 at 45 degrees and 225 degrees as well. This is because all functions are positive, only sine. Here, only tangent is positive. That's all students take cosine. Tangent's positive in the third quadrant as well as the first quadrant. Now, where does arctangent live? Arctangent lives in either quadrant 1 or quadrant -1. So the value that works for us is 45 degrees. And that's it. Use a calculator to find the acute angle alpha to the nearest tenth of a degree that satisfies the equation sine alpha equals 0.3114875. So with our calculator, they ask for the nearest degree. So we want to make sure our calculator is in degree mode. So take a moment and get that done. And essentially, the answer is going to be when alpha equals arc sine of 0.3114875. However, we need to make sure that we understand that there are an infinite number of solutions for sine alpha equals a number like 0.3, etc. Infinite number of solutions, because you can keep going around the circle in the first or the second quadrant and find coterminal angles where sine will still be 0.311. But as soon as we go to arc sine is a function, and for each input, like this one, you only get one output. So you will only get one solution, and the solution will be something either in quadrant 1 or in negative quadrant 1. That's where arc sine will give you an answer. So we just have to make sure we know if that answer is what they want. And they just said the acute angle meaning between 0 and 90. So arc sine gives us those kind of values, so this is just fine. But if they had said the angle was in the second quadrant, then we would have to convert. We would have to take our answer and subtract it from 180, or depending on where your answer needs to be, arc sine won't always give it to you. But this one should be fine. So I'm typing into my calculator. And it gives me the arc sine equals 18.1489, etc. Now they ask for the nearest tenth of a degree. So we take a look at the tenth, this 1. The 4 does not round it up, so we would just have alpha equaling 18.1, and make sure you use your degree symbol. Otherwise, it's radians, even though you don't mean to have it be radians. Okay, great. Find alpha to the nearest tenth of a degree where alpha equals arc cosine 0.2692789. Now arc cosine is a function, so this one input will only give us one output. To understand where arc cosine might give us an answer, arc cosine either lives in the quadrant 1 or into quadrant 2. So when you use arc cosine, in your calculator, you will either get a quadrant 1 angle if you put in a positive number like we're doing here, or you'll get a quadrant 2 angle if you put in a negative number into arc cosine. So we expect a positive number. Make sure your calculator is in degree mode. If it is in radian mode, you will not get the correct answer. And the answer is alpha equals 74.3786 degrees. They wanted the nearest tenth of a degree, so we take a look at the tenth, the 0.3, and notice the 7 will round that up to 0.4. So we end up with an answer of alpha equals 74.4. Make sure you use the degree symbol, or else you will be saying your answer is so many radians. Okay, great. We want to find sine alpha. When you have a triangle, one of the best techniques for finding sine, cosine, tangent, and the reciprocals is SOHCAHTOA. For whatever reason, that seems to stick in students' brains. SOHCAHTOA. Go soak your toe. SOHCAHTOA. This stands for sine is defined as opposite over hypotenuse. So O is opposite, H is hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the O is for opposite, the H is for hypotenuse, the A is for adjacent, S is for sine, C is for cosine, T is for tangent. In our case, to do sine alpha would be the opposite over the hypotenuse. Now for this problem, from alpha's perspective, the opposite is 24 and the hypotenuse is 30. So this would be 24 divided by 30. Now if we divide by 6, 24 divided by 6 is 4, 30 divided by 6 is 5, and we can reduce our answer to 4/5. Find tangent alpha. Well, from SOHCAHTOA, we see that tangent is opposite over adjacent. From the alpha's perspective, opposite is 15, adjacent is 36. So tangent of alpha would be opposite over adjacent, and that would be 15 divided by 36. And then you can reduce this by dividing by 3 and getting 5/12. And that's that. Find cosine beta. Well, from SOHCAHTOA, we see that cosine is adjacent over hypotenuse. Cosine beta is adjacent over hypotenuse. In this case, from beta's perspective, adjacent is 120 and hypotenuse is 123. You can divide by 3. 120 divided by 3 is 40. 123 divided by 3 is 41. And that's the value for cosine beta. Solve the right triangle with the given sides and angles. We have A, lowercase a, so that's a side, equals 3.0, that's the length of that side, and beta, Greek letter, that would be an angle, that equals 28.1 degrees. So let's draw a triangle. And the angle, we have a right angle, 90 degrees. We have a 28.1, so I'm going to put that one in the one that's the smaller angle, how I drew this triangle. And now where does A go? What's important about setting these triangles up is they use regular lowercase letters usually for the side and Greek letters for the angle. And the Greek letter, beta, is B in the Greek alphabet. So the beta angle is the opposite of the B side. So this over here, this side, is not going to be A, it's B because it's opposite of beta. So we're going to put in B there. Hypotenuse is always C. A is 3.0. And opposite of A is the angle alpha. So make sure when you're setting these up, it's not as important where you put this 28.1 of the two non-right angles, but what is important is that it's opposite the appropriate side. So make sure that you don't set an A and a beta opposite each other, or you will not be getting the correct triangle. Now that we have this set, we want to solve the right triangle. That is, solve for the missing pieces. We have three pieces that are missing: alpha, B, and C. Alpha is probably the easiest to find because alpha and this angle are complementary, meaning they add up to 90 degrees, meaning that you can find alpha by taking 90 degrees and subtracting from it 28.1 degrees, and we get alpha equals 61.9 degrees. That's one of the three pieces that we were missing. Next, I always like to use the information that was previously given, so the A and the beta, to find anything else. So I'm looking for a trig function that has to do with this angle that somehow uses the adjacent side and gets me either the opposite or the hypotenuse. So if we look at SOHCAHTOA, we are trying to find, again, from this angle that we're given, the perspective, something that uses adjacent and gets us one of the sides that we're missing. Well, there's two that use adjacent, either cosine or tangent, and they will both be great. In fact, you might consider using each one. So starting off with cosine. Cosine of beta, 28.1, the one that was given to us. That would be adjacent, 3.0, over hypotenuse, C. Now, solving for C, you get C equals 3.0 divided by cosine of 28.1. Make sure you're in degree mode, and you get C equals 3.40087, rounding to one decimal place, as A and beta are both in one decimal place. This is 3.4. So C equals 3.4. Now, tangent also uses the adjacent. So again, we want to use the angle and what was originally given. So let's try tangent. Tangent of 28.1 degrees would be opposite B over adjacent 3.0. Solving for B, we get B equals 3.0 times tangent 28.1 degrees. Plugging this into your calculator gives you B equals 1.6018, rounded to the nearest tenth, like the original information, 1.6. Okay, so we have found the three missing pieces. To reiterate, I think it is very important that you try to stick to one of the trig functions that uses an angle that was given and the side that was given, if possible, and it is possible. If you're given two sides instead of an angle, then use a trig function that uses both of those two sides. But try to use the original information. That way, if you were to have made a mistake somewhere up here in alpha, well, you didn't use alpha for the rest of the problem, so you didn't compound your mistake, and you might only lose partial credit doing it that way. The other thing you might wonder is the step to solve for C here. Essentially, you multiply the c up to the other side, and you divide by the cosine down. And so the c and the cosine essentially change places. This solving for b is a little more straightforward. You multiply by the 3. And now coefficients almost always go in front of a trig function so they don't get confused with the angle. Okay, great. Solve for the right triangle given beta equals 43.2 degrees and c equals 2.2. So let's start with a triangle. Right triangle. Beta, I'm going to put that here, although it doesn't matter. And c is the hypotenuse. So we're missing alpha. Opposite of alpha would be the side A. Opposite of the given beta would be side B. Make sure your alpha A and beta B are opposite pairs. Okay, now that we have this set up, we see that we need to solve for A, B, and alpha. Alpha is the easiest because alpha and 43.2 degrees are complementary, meaning they add up to 90. Meaning you can find alpha by subtracting from 90 degrees 43.2 degrees, giving us alpha equals 46.8. 46.8 degrees. So that's the easiest. On a right triangle, if you're given one of the acute angles, the other angle is easy to get. Now, for the other sides, the A and the B, we can use the fact of SOHCAHTOA, telling us that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. From our angle's perspective, we know the hypotenuse. So we want to use one of these that has hypotenuse in it. And both sine and cosine are great examples. In fact, I'm going to use one of each. So starting off with sine. Sine of my angle, 43.2 degrees, equals opposite, B, over hypotenuse, 2.2. Solving for B, I get B equals 2.2 sine 43.2 degrees. And my calculator gives me 1.5060. The initial information has one decimal place, so we go rounding to ours to one decimal place. 1.50 would go to 1.5. 1.5. And we found B. Now we use sine because sine used the angle that we were given and the hypotenuse that we were given. Next I'm going to use cosine because it uses the angle we were given and the hypotenuse we were given as well. You might consider using the Pythagorean Theorem because if you know two sides of a right triangle, you can find the third one with the Pythagorean Theorem. The only reason I wouldn't do that is because I found B. I wasn't given B. And so if I made a mistake getting B and I used that in the Pythagorean Theorem to find A, well, I've compounded my error and I'll get that part wrong as well. Instead, I'm going to go back to the original information. Cosine of 43.2 degrees will also utilize the hypotenuse. Adjacent A over hypotenuse 2.2. Make sure when you're doing cosine of 43.2, it's from the 43.2 perspective that the adjacent is pulled. And in sine, it was from this perspective that the opposite, B, was used. Solving for A, we get A equals 2.2 cosine 43.2 degrees. And calculator gives us 1.6037. Into one decimal place, 1.60 will be rounded to 1.6. And we have solved this right triangle. As far as do these values seem about right, if the hypotenuse is 2.2, that's the longest side, so B and A should be less than that, and it is. The angles 43.2 and 46.8 are very close to the same, meaning their opposite sides, 1.5, 1.6, will be very close to the same as well. The larger angle is alpha, and so its side will be a little bit larger, which it is. So everything feels great about this problem. Great. Solve the problem. The angle of elevation from a point on the ground to the top of a tower is 38 degrees 39 minutes. The angle of elevation from a point 111 feet farther back from the tower is 27 degrees 36 minutes. Find the height of the tower to the nearest foot. Sounds like there's a lot to this problem. I'm going to start off by noticing we have 38 degrees 39 minutes and 27 degrees 36 minutes. The minutes is not something that's easily plugged into your calculator. So I'm going to convert these to just decimal degrees. So 38 degrees 39 minutes is 38 degrees plus 39 over 60 degrees. And our calculator gives us 38.65 degrees. And our other one, 27 degrees 36 minutes, is computed to decimal the same way. Oh, not that same. 27 degrees plus 36 divided by 60. And a calculator gives us 27.6 degrees. Put a little degree symbol there as well. So we've converted from degree minute seconds to decimal degrees. Now that we've done this, let's see if we can figure out our picture. The angle of elevation from a point on the ground. Okay, here's our point on the ground. The angle of elevation is based on the horizontal. We said there's a tower. Here's our tower, and they want to find the height of that tower. The angle of elevation is, if I finish this triangle, looking from horizontal and elevating your head up to see the top of the tower. So this one is 38.65 degrees. The angle of elevation from a point 111 feet farther back, so if we go an additional 111 feet, so this is 111, just from there to there, and look at the top of the tower. Now the angle of elevation is 27.6 degrees. So this is the picture that we have, and we're trying to find the height of this tower. So, from either angle's perspective, the information that we're given, the angle, we want to find the opposite. And we only know anything about, from the angle's perspective, adjacent. And we don't even know all of the adjacent. But we do know we want opposite, and we know something about adjacent. So this speaks to that we're going to use tangent, which is opposite over adjacent, SOHCAHTOA. So we're going to work with tangent. And for this 38.65 degrees, the adjacent, we don't even have something there to call. So I'm going to make up a variable x right there. Now we can get a little more room, move that to the top. We can set up, first off, from the 38.65, we can set up tangent. And this would be tangent 38.65 degrees equals h over x. Now solving for h, because that's what we're trying to find, we'll find h equals x tangent 38.65 degrees. We're going to need this, so let's make sure we highlight it. Now we have another triangle. This larger right triangle, we can also do tangent of that. The reason why this is not enough is we don't know what x is. We haven't used the 111. The 111 is involved with the larger triangle. So in order to use the 111, we do have to write something about the larger triangle. So let's write down the tangent for that one. Tangent of 27.6 degrees would be opposite h over, now the adjacent is the sum of these two. It would be x plus 111. So the length of this side is x plus 111. Now let's solve for height there as well. The height is going to be x plus 111 tangent 27.6 degrees. Alright, so what we have here are two equations and x and h, two unknowns. This is just a system. So thinking in terms of elimination or substitution, we know that we can solve for whatever we want. Now the way they're written now, we solve for h in both cases because that's what we want. If I were to set these equal, because h is equal, if I were to set these equal, I could find x. And there's no fractions in how this is written, so that shouldn't be too hard to find x. Once I have x, I can plug it back in here and calculate h. So that's how I'm going to do this. I'm going to set these two equal to each other. I'll put a box around this one as well so you can see. I'm going to set them equal because, in fact, h is equal, so these must be equal as well. I just need more room. This is the long problem. All right. So we have x tangent 38.65 degrees equals x plus 111 tangent 27.6 degrees. We want to solve for x. So first we simplify. We simplify by distributing the tangent through this parenthesis in reverse and getting x tangent 38.65 degrees equals x tangent 27.6 degrees plus 111 tangent 27.6 degrees. Okay, closer. We're trying to solve for x, so I'm going to subtract this term, 27 points, the x tangent 27.6 to the left, so the x's can reside on the same side of the equation. This is the most algebra I've done for a while in trig. We now have x tangent 38.65 degrees minus x tangent 27.6 degrees equals 111 tangent 27.6 degrees. Closer still. More room needed. Solving for x. There are x's now on the left side. However, because these tangents are not the same, these are not like terms. So instead of just subtracting them, we have to factor out the x. So we have tangent 38.65 degrees minus tangent 27.6 degrees equals 111 tangent 27.6 degrees. I'll close my parenthesis. Good. Now at least we have 1x to solve for. So now we have to divide by all of this stuff on both sides. And I'm not going to write that down just because it's getting really long, but hopefully you can see from the answer what has happened. X equals 111 tangent 27.6 degrees divided by the sum, tangent 38.65 degrees minus, not plus, go minus tangent 27.6 degrees. This is now something we can plug into our calculator. That's crazy. And let's do that. What's important about this is that you put a parenthesis around the denominator, because this is going to have a lot of operations involved, and you want to make sure all of it is going to be what's divided into the 111 tangent 27.6 degrees. So now go to your calculator and give you a moment. And your answer should be, you might want to pause the video as you do this. Make sure you're in degree mode as well. It is 209.5439. And I'm not rounding any of this yet. In fact, I'm going to leave my calculator. I'm not going to clear it. So this number is on my calculator screen for when I solve for h. I will just be able to use what's on the screen and not lose any information. Wow, so we've solved for x. Now we need to solve for h. So I need to go back and remind myself the nicest h expression. Here we have it. H equals x tangent of the 38.65. And here we go. H equals x tangent of the 38.65 degrees. So what's on my screen right now is the whole 209.7 decimals. I'm going to just take that and multiply that by tangent of 38.65 degrees. In this way I haven't lost any information. And I get 167.576. And now I need to go back to the original problem and find out what kind of answer they wanted. Okay, here we go. Find the height of the tower to the nearest foot. So the nearest foot, so we're going to round to 0 decimal places, and it's going to be feet. So we come back down, and then, since this was a story problem, let's see, rounding to the nearest foot here, the 5 is going to round this up to 8. So we have 168 feet. They asked for the height of the building, the tower, and we have found it. And that's one of the longest problems in trig to solve in applications for a while. Great. When sitting atop a tree and looking down at his pal Joey, the angle of depression of Mac's line of sight is 31 degrees 9 minutes. If Joey is known to be standing 33 feet from the base of the tree, how tall is the tree to the nearest foot? Okay, first off, we have a degree minutes, and we'll want to convert that to just degrees, decimal degrees. So let's start with that. 31 degrees, sorry. Come on. There we go. 31 degrees 9 minutes is 31 degrees plus 9/60 degrees. Dividing the minutes by 60 gets you degrees. And our calculator gives us 31.15 degrees. All right, so now that we have this, we can now work on the picture. What kind of picture is this? So we have a tree, and we have this guy sitting, Mac, I guess, Mac's sitting on the very, very tip top of a tree, which is really hard to do. And he's looking down at his pal Joey, standing 33 feet away. Okay, so we have a tree. And how tall is the tree? Let's call it H. 33 feet away. Here's his pal Joey. So here's Mac, here's Joey. And now they say the angle of depression. The angle of depression. So if Mac were looking straight out horizontally, and then he looked down at his friend, how far down he would have to put his head is the angle of depression. So they're actually giving us this angle, not the angle in the right triangle. So we'll want to convert and find the angle in the right triangle. Shouldn't be too hard. So this is the angle we want. And these two angles are complementary. You can see that they add up to a right angle. So we just have to subtract. If we do 90 I'm having a hard time with this pen today. Now it won't erase. Okay, fine. 90 degrees minus 31.15 degrees. And use your calculator, you get 58.85 degrees. So this is the angle that we're going to work with. So there's a little bit of work to get to it. We had to first get to decimals and then subtract from 90. But now we're set to go. Now, from this angle's perspective, the information that's provided is the opposite, and the information we want is the adjacent. So you want to think about, in terms of SOHCAHTOA, which sine, cosine, or tangent uses, again, opposite and adjacent, and that would be tangent. So we're going to set up a tangent. So let's just jump straight to it. Tangent of this 58.85 degrees is opposite, 33, over over adjacent, h. I saw the h and thought hypotenuse. Well, let me make a little more room. Solving for h. H would be 33 divided by tangent 58.85 degrees. And to do this, basically you move the h up with multiplication, then you move the tangent down with division, and that's what you get. And now we go to our calculator, and it gives us h equals 19.946, and a lot more decimal places. But if you recall, we'll go look at that. This problem asks for to the nearest foot, so we're going to round to 0 decimal places. So in this case, we're going to round. This 9 is going to round up, and we're going to get h equals 20 feet. Okay, don't ask me how he got up on the very tip top of a 20-foot tree, but we have solved this problem. Great. The chairlift at a ski resort has a vertical rise of 3,400 feet. If the length of the ride is 1.8 miles, what is the average angle of elevation of the lift? Okay, so we have the vertical rise is 3,400 feet. The length of the ride is 1.8 miles. I'm not going to like that very long. Let's see, 1.8 miles. See, the issue here is we have miles and feet, and I either want to go to miles or feet. So I'm going to convert the miles to feet. And to do that, you multiply by the conversion factor. 1 mile is 5,280 feet. And then we can cancel out the miles, and we end up with 9,504 feet. So that's really what we want here, 9,504 feet. Okay, so we have the vertical rise of the chairlift is 3,400 feet, and 1.8 miles, the length of the ride, or 9,504 feet. Now they want the average angle of elevation. That would be alpha. Okay, so now that we have this, we can ask ourselves, from this alpha's perspective, and again, angle of elevation, how far would you have to tilt your head up to see the top? From that perspective, what trig function uses opposite and adjacent? And that would be tangent. So we would set up tangent alpha equals 3,400 divided by 9,504. Now to find alpha, alpha is going to be arctangent of 3,400 divided by 9,504. And this is now what I would plug into my calculator. Make sure you're in degree mode. and you get alpha is 19.684-ish degrees. And let's go back and take a look. They want to the nearest tenth of a degree. So we want to get to the nearest tenth. So this 8 is going to round this up, and we're going to get 19.7 degrees. And that's it. Great.